Hello, ladies and gentlemen, and welcome, everyone. Welcome. We're going to finish off our 2011 Grade 7 Gauss paper in this very video. That's right, we're up to question number 25, so let's get ready and take a look. 10 circles are all the same size. Each pair of these circles overlap, but no circle is exactly on top of another circle. So we could have things like... all of them have to overlap. So maybe they're all sort of intersecting like a Venn diagram. Or maybe, they're all just, they happen to be close enough. I guess these two outer ones aren't overlapping. But okay, every one of these circles overlaps. Each pair of these circles overlaps. What is the greatest possible total number of intersection points of these 10 circles? Okay. So what can we do? Well, we could experiment with smaller cases. Certainly, if I just had 2 circles, what's the most they could overlap or intersect? Well, just with 2 here. 2 points there. What if I had 3 circles? And I'm going to draw them, actually, I'll draw them a little bit bigger. And just very, very close to each other so that we do get overlaps. And what overlaps do we have? 1, 2, 3 down here. 1, 2, 3 up here. So in total we get 6 if we've got 3 of them. We've got 2 if we've got just 2 circles. Okay, we could explore a little bit more with 4, although I think the picture is going to get a little messier. I'm just trying to make sure that every pair of circles has some overlap. And there we go. I'm not so worried about size. And then what have we got? 1, 2, 3, 4, 5, 6 down here, and we should get 6 up here as well. So, okay, we got 2, and then 6, and then 12. We could try and find a pattern out of here. We absolutely could. Instead, we could try and think our way through the question. What possible pairs are there? Well, there's 10 circles that I could choose. And then there's 9 circles that I could choose to pair it with. Circle A gets paired with circle B. Or circle A gets paired with circle C. Or circle B gets paired with circle D. There's 90, it looks like, pairs. But of course we have to remember to divide by 2. Why are we dividing by 2? Because if I choose A first and then pair it with circle B, assuming that, say, my circles have names, I get the same pair as if I chose B and then chose A. It's the same pair, so I've counted every pair twice. So it turns out we get 45 pairs of circles. Right? If every pair of circles overlaps, then I'm going to get 45 sort of circle overlaps. So circle intersections, right? Well, if I have just 2 circles, if I'm just tunnel vision on A and B or circle C and I, what possible intersections could they bring to the table? We already know the answer to this. We saw it with our first example. If I just look at just 2 circles, they will have at most 2 intersections. Of course, they could intersect right at a single point, but we want as many intersections as possible. So if all my circles intersect with 2 points, or all my pairs intersect and give me 2 points, and I've got 45 pairs, our answer should be 45 times 2, which would be 90. Now, does this make sense? If we're going to think our way through the problem rather than try and recognize a pattern, does this make sense with the answers we've seen so far? If I've got 2 circles, how many pairs should I be able to have? 2 times 1 over 2 is 1. Times 2 intersections per pair. And yeah, 1 times 2 gives me 2. What about 6? Well, that comes from 3 circles. If I have 3 circles, 3 times 2 over 2, there's 3 ways to intersect my circles. The green circle could intersect with the purple circle. That's one way. Or the purple circle could intersect with the pink circle. Or the pink circle and the green circle could intersect. Doesn't have to be a particular order. So yeah, that's 3 intersections. Each of them giving me 2 intersections. Here's the purple and pink, green and pink, and then green and purple, and yeah, everything's working out. We get 6. We could check for 12 as well. But here we go, we get our answer of 90. Okay, is 90 one of the possibilities? Sure it is, it's right there, it's D. Okay, so you could think your way through the problem, that's the way we did it, or you could say, 2, 6, 12, the next one's going to be 20, and then after that it'll be 30, and you might say, oh, I recognize a pattern, it's just products of consecutive numbers. This is 1 times 2, this is 2 times 3, this is 3 times 4, the bigger number being however many circles you've got. That's another way to see it with pattern recognition, and both give you the answer of 90, which is what we want. So there we go, that closes off our 2011 grade 7 Gauss. Now, of course, there's still a grade 8 Gauss if you're looking for a bit more of a challenge. So feel free to download that contest and try the grade 8 Gauss for this year. If you're looking for more grade 7 Gausses, feel free to browse around the channel. Feel free to leave a comment if you had a different way to do the question, or to throw a like on the video if you've been liking the contests so far. But other than that, I wish you all a wonderful day, and I'll see you for more math in another video.